All right, here we are. We're going to talk about the 2016 question 6 on series from the BC test. All right, let's just dive into it. It says the function f has a Taylor series about x equals 1. So if you're using the definition, this is like your a value that converges for all f of x in the interval of convergence. That usually shows up as something like this, where you have to find endpoints. It is known that the first term is equal to 1, and f prime of 1 is equal to negative 1/2, and the nth derivative is given by this. The first thing that I just want to remind you of is that remember that the Taylor series looks something like this, where you have f of a plus f prime of a, x minus a, plus f double prime of a, x minus a squared over 2 factorial. And so the first mistake I don't want you to make is that is just the derivative part. And so this is not going to give you the entire series. It's just going to give you the coefficients, essentially, the derivatives. You still have to put in the other pieces to it, if that makes sense. So, all right, write the first 4 non-zero terms and the general term of the Taylor series about x equals 1. And so if we jump down here, just kind of walking you through this, what was found is the first 4 coefficients using this thing up here. And so the second derivative with a 1 plugged in is 1 over 2 squared, 2 to the second, and the same process for this. And so if you're asked for the actual Taylor series, notice that you're going to take the coefficients. So 1 is here, that's f of a, that's 1. F prime is negative 1/2, and then you have to put in your x minus 1. The second derivative, the coefficient here, is 1 over 2 squared. And then if you look here, this 2 comes from the 2 factorial from definition, and then this x minus 1 again comes from the definition to the second power, and the same holds for the third term. You have a 3, what's supposed to be a 3 factorial, but that 3 times 2 cancels out with that 2 up there. So that's where that comes from. Okay. If you look for the patterns down here, you can apply this with n's, and it looks like maybe n starts with 0. You start throwing stuff to the zeros in here, you get a bunch of 1s, which is going to turn out to that. All right, the second part, it says the Taylor series about f of x equals 1 has a radius of convergence of 2. Find the interval of convergence. So if you know that this has to be centered at 1, so the center of this thing, think of it as 1. If the radius of convergence is 2, that means you want to think of this going out 2 units and out 2 units in both directions. And so you can think of the interval of convergence being negative 1 to 3, or if we're doing it kind of like we did it in class, you can think of it as like that. These are 2 different ways to write it. And so if you jump down here, you see that show up. That's where those numbers comes from. So we got a point for identifying the endpoints. And then I haven't talked about this too much yet. A couple of you have asked me individually, but the last thing to kind of ask yourself is, it converges on every value in between negative 1 and 3, but does it actually converge at the endpoints? Does it converge at the number negative 1? Does it converge at 3? And so if you're looking for every last detail on this, what did I have here? It was centered at 1, less than 3. then we want to know, do we have to include those endpoints or not include them? And so if you look at this analysis here, if you take your series, which we found up here, 1 minus 1/2 x minus 1 plus 1/6 x minus 1 squared. Is that 6? No, that should be like an 8. And you actually evaluate this with the value x. So meaning if you plug in x here, you plug in a -1, so I'm testing an endpoint, we get a -2. -2 times this would become a 1. And you plug in a -1 here, and it looks like you get a 1/2, 1/3, a 1/4. And what you have here is you have the harmonic series. The harmonic series was the series as n goes from 1 to infinity, and that diverges. That was at the bottom of that sheet I gave you in class. Whew, lots of details. If you do the same thing for 3, meaning you take 3 and you plug it into this equation, so you get 1 minus 1/2, 3 minus 1 plus 1 over 2 squared times 2, 3 minus 1 squared, and you end up getting this. There's something that keeps showing up on some of these FRQs, and it's called the alternating series test. And if you have any series that alternates signs and decreases, meaning each term is less than the previous term, so 1/4 is less than this, then it is going to converge by what we call the alternating series test. So that means that it converges at 3, and to get both of these points, you'd want to have a less than or equal to sign there. Okay, part C says the Taylor series for f about x equals 1 can be used to represent f of 1.2 as an alternating series. Use the first 3 non-zero terms to approximate it. So, not worth very many points, but the idea with these Taylor series is you're using a polynomial to approximate something that's not a polynomial. And so all you have to do for part C is substitute your x value, which was 1.2, into your series and come up with an answer. And so the approximation for that is 0.905. You get a point, you don't get a point. All right, part D, last part, it says show the approximation found in part C is within 1/1000th of the exact value of f of 2. So this doesn't say it, and we started talking about this a little bit today in class, but it's referring to the error, even though it never uses that word error. Remember, when you see this within anything, within a fraction of something, it's referring to error. And the error essentially is the difference between a function, and this t stands for your Taylor polynomial that goes up to your second degree. And so remember back when we did linear approximations, if we have some curve and then some linear approximation, right around this area, it's a very good approximation. In fact, at that point, it's exact. And then as you get further and further away, there's this difference between the two functions, and this error is a lot, and this error is a little. And so when you see it written like this, that is just a fancy way of writing error. What's happening between the two things. And so the strategy here is the error can be determined by evaluating the next term, the n+1 term in the series. So this is also sometimes called the Lagrange error, if that happens to come up on any of your study guides. And so if the idea is that we're approximating the second term here, then in order to find our error, what we want to do is look at the next term, the third derivative term. And so if we go up here, our third term looks like this. So we got 1 over 2 squared. Wait. Now I'm confused. Okay, we did 3. I'm sorry. We did 3 terms. So this is the second degree, but if we did 3 terms, we want to use the next term, which is the fourth term, which is the third derivative. This can get a little bit gnarly. And so my approximation in part C used the first 3 terms. And so what I'm going to use is this thing right here. And to find the error, I'm going to use this 1 over 2 cubed times 3. But my x value is the x value that I'm trying to find the error of. And so I would put a 1.2 minus 1 cubed. When I evaluate this, I'm going to get some number. I'm going to get some fraction. And that fraction, if I did it right, should be less than that number. If it's less than, you're saying it's within that error range. And so let me scroll back down here. So I've got 1 over 2 cubed times 3. And then I've got 1.2 minus 1, which is how they get this 0.2, and then cube it. And so, you've got 8 times 3, you've got 1 over 24, and then you times that by some other small decimal, and you end up getting 1 over 3,000, and that's less than 1 over 1,000. And so we've shown that the error fits the criteria. Hopefully that helps a little bit. I'm going to try to do another one right now, but the big thing to take away, even if it's not crystal clear at this point, is that this error is always going to be determined by evaluating the next term. If you did a Taylor polynomial with 3 terms, then you'd use the fourth term to find it. If you did an approximation with 2 terms, then you'd use the third term to find it. It's always the next term. So, all right, thanks for watching.